For the most part, the arborist aloft is just going to do what we call cut and chuck. They're going to have a piece of wood that they're going to cut, and they're going to drop it into the designated drop zone. Your role as a ground worker is going to be responding to the audibles and staying clear of that drop zone. Again, the audibles will be stand clear, and your response will be all clear. And then they can just throw that piece into the drop zone. However, there is numerous times throughout the day and throughout your career that you're going to run into situations where there's highly valuable stuff below you, and you're going to have to rig those pieces down. A really simple setup is to run the rope through a natural union. With a natural union, you are going to be receiving a lot of friction on that branch. You, as a ground worker, will find a benefit in this in lowering, in that piece, let's say it weighs 10 kilograms, if in a piece like this you'll be getting about 50% friction, you'll only have to hold about 5 kilograms on your side. However, that becomes a major disadvantage if for whatever reason you need to pull that up. You're going to have to overcome that friction. Now in this case, because of that 50% friction on that natural union, you're going to have to pull twice the amount of input load on your side. If we're getting into bigger rigging or heavier rigging, we want to move up to an arborist block and put in some heavier ropes into this situation. So let's take a look at that. Moving over to a block, what we have is far less friction, and the blocks will have efficiency for each block. If you go in the manual, it could be 90% efficient, 85% efficient, but they'll all state that efficiency in there, and that's referring to how much friction you're getting through that piece. When we run a piece through here, again, we're getting less friction, which means less wear and tear on our equipment. But you, as the ground person, need to realize that you will now be carrying closer to the weight of that piece. We also need to factor in dynamic load when we're running these pieces. If there's going to be a piece that's run above our rigging point and it's dropping into this load, we've got to compensate for that dynamic load. So if you think that piece is around 20, 30 kilograms, you have to anticipate that vastly increased load and dynamic load and make sure that you can handle it. So let's grab a piece here. We're going to run this piece of wood through this block here, which is conveniently set up in the tree for us. One point of view with these particular blocks is to make sure that that pin is in the locked position. So as we push that through, we want to make sure it seats in the closed position. Here now, as a ground person, you are going to be holding the full weight, or as close to that full weight as possible. You're not getting as much friction, so lowering it, you're going to be producing a fair bit of heat on these things right here. I highly encourage you to wear gloves. In fact, you're going to be melting your hands if you're not wearing them. So make sure you wear gloves. If you do have a need to lift a piece up though, it's far easier with this piece because we have less friction. Let's just talk about some of the loads we're experiencing here. With this setup, if we're in an ideal world without friction, if this piece here weighs 10 kilograms, for me to hold it in an ideal world, I would need to hold 10 kilograms. Meaning this leg of rope has 10 kilograms, this leg of rope has 10 kilograms. So the block will be experiencing twice that load, which in this case would be 20 kilograms. The good thing about this is we've upped our rope. This rope here in particular, we wouldn't want to run on a natural union. This has a lot more strength. We've upped our rope to be able to compensate for the increased load as well. let's talk a little bit about friction. We always have gloves on when running a rope. A little bit of pressure with our hands adds that much needed friction to the system to slow that piece down. However, we're going to run into situations such as in a dynamic load or when the piece exceeds our weight that we're not going to be able to hold that piece. And I really don't want to go to the top and meet the climber because that piece exceeds my weight. What we can add in the system to help us is devices such as this porter wrap to control the friction. In the old days, we used to just take wraps around a tree. The byproduct of friction is, again, heat, so we had a lot of wear and tear on a rope and on the tree. The tree also was inconsistent between bark diameter and texture. With the porter wrap, we're very consistent every time with how much friction is being applied. In fact, each full 360-degree wrap on the porter wrap is good for 330 pounds. To load this porter wrap, we're going to take a bight of rope and we're going to pass it through the porter wrap into the retention pin. One full wrap is going 360 degrees around. That would be good for 330 pounds again. So now, as that piece is coming down, we can let the porter wrap take the load. If for whatever reason we needed to lock this off, we would want to fully load the barrel, meaning take all the wraps we can onto the porter wrap. And at the end on the retention pins or the cleat pins, we're going to do 2 half hitches, one on either side. The reason for this is if we had a heavy piece, we just did one wrap and we went right to our half hitches, it would be next to impossible to untie these half hitches. By fully loading the barrel and taking all those wraps, they're taking the load of the piece. There is literally no load on these half hitches, and this becomes easy to untie and then to lower the piece or move the piece appropriately. That's friction.
All right, great. So we've gone over our regular basic rigging setup. Now we're going to go over a scenario where you might find yourself not wanting to be rigging for your climber anywhere within that drop zone. So your porter wrap is on the base, you're standing a distance away. What if that top that's coming down is dead? What if you're worried there could be some debris, some shrapnel that might come flying out, and you want to put your groundsperson out of that zone? Pretty simple way to do it is to redirect the rope in what we call a square rig. So pretty simple basic setup, but you need to understand the forces involved and why this needs to be done. What you might think is the rope coming down to the porter wrap, you just want to put the porter wrap away and out of the zone. So why not just pull this rope over here? Save yourself the hassle, the equipment. Huge problem in doing that is a force we call a bending moment. So best way to describe that, I find, is just with a regular stick. Say this is your tree. You can pull that tree and not break it. You could push down and compress that tree and probably not break it. But what about if you bend it? Trees are not strong in their bend. They're strong in compression and tension. That's pretty much it. So the problem with just pulling this rope and say going over to a porter wrap at a certain distance is you're creating a bending moment on that tree for that climber. Big, big no-no. So to compress those forces, we put a block at the base of the tree to redirect that rope down. So all those forces are coming down back to the porter wrap. So you're in a safe position, but the forces haven't changed. All right, so our piece has come down. We've mitigated the risk of the bending moment of that load by putting in this square rig, but there's still objects to avoid once the piece comes down. Our climber has put on a tagline, a simple piece of rope onto the piece so that when it comes down, I can have another ground worker help me pull the piece into a safe landing area. So Ken, you want to give me a hand for a minute while we lower this piece down? So Ken's just going to grab that rope, and together we're going to lower and pull the piece. Now all I ask of Ken to do is not put too much force on that while I'm lowering it, because the whole point of this was to reduce that bending moment. If he pulls too hard, or if we put a machine on that or something like that, we're just going to end up putting the bending moment on that we were trying to avoid in the first place. So Ken, if you want to lower slowly, I'll lower with you. Okay, looking good. Nice and easy. Trying not to shock the rigging point. And we're done.
All right, here we've hooked up the load cell to the piece that we're rigging down. The load cell is currently reading 16 pounds, meaning our input force is 16 pounds. In order for me to keep this load static, I also need to hold 16 pounds. And the block, in this case, we'll be receiving twice the load. Let's switch the location of this load cell up to the block or the anchor to see if we get the same numbers we're theorizing. So we'll lower this down, switch a few pieces out. All right, so take that block off up there. Okay, here we go. Unscrew this. And what we will do is we'll link the bushing of the block with this beaner and attach it to the dead-eye sling at the top. I'll have to go through that dead-eye sling first. Roll that around and get the block in there. Okay, now what we have is the load cell up at the anchor. You can already read that we're fluctuating between 2 to 4 pounds. That's to accommodate the additional load of the block and gear. So when we attach this rope to the sling again, we'll have to factor that additional weight into our calculation. We'll bring this rope up, we'll put it into a static load, and you can see we're getting between 38 and 40 pounds. Again, we had to add the additional weight of the block, but we're receiving twice the load of the piece on our anchor. That's in a static situation. If we can look at those numbers and we start to jump them, we can see our numbers fluctuate around. I'm getting 78, 80 pounds just by little movements there. So realize the dynamic load is really going to increase it. We can calculate the static load fairly easily, but we need to also factor in that dynamic load when rigging.